We have a problem. The internet is broken. We don't have enough IPv4 addresses. But what are IP addresses? Well, IP addresses are IP stands for Internet Protocol, and an IP address is a unique identifier for something that's connected to the internet. The internet is a huge network that connects a lot of computers, phones, routers, and different devices across the world. We need IP addresses the same way we need phone numbers. If you want to call your friend, you need to know their phone number, and they have to have a unique phone number. If multiple people could have the same phone number, we would have a problem, because when you call that number, your telecom operator wouldn't know exactly who to send it to. So phone numbers are unique. IP addresses are unique too, and they solve the problem of routing. So what we do is we have the internet, this huge network with a lot of devices, and we assign each device a unique IP address. With this IP address, we can forward or route packets to that destination. So if I say I want to connect to Google address, first we will have to retrieve the Google IP address and then send it there. This is done with what's called DNS. And DNS is kind of an address book. So in an address book, you have names of your contacts and you translate that into phone numbers. DNS is exactly the same for domain names like google.com and IP addresses 1.1.1.1. So why do we have a problem, and why did we say that the internet is broken? The internet is not broken, but we do have a problem. There are only 2 to the power of 32 IPv4 addresses. You might think that this is a lot, but it really isn't. There are only 4 billion IPv4 addresses in the world. 2 to the power of 32 is a bit more than 4 billion, but still, there are some addresses that cannot be used for public IP addresses. These are the ones that we are concerned about. And currently, the world population is already more than 4 billion. So with more and more people getting access to the internet and people having more devices, this could be a problem. Of course, you don't need one IP address per device. You don't need one IP address for your laptop, one IP address for your phone. No, it doesn't work like that. But still, you need one IP address per router in a home or for servers that usually they require, or it's better if they have a unique public IP address. The situation right now is that the demand for IP addresses keeps growing, but the availability of them doesn't. It's a fixed number. And currently they are being sold for more than $50 each. Originally, they were distributed and a lot of them were given for free to institutions and countries. But nowadays, there aren't any IP addresses that are not assigned to someone already. So if you want one, you have to buy it from someone that has it already. A lot of countries and telecom operators cannot give a unique public IP address to their customers. And that's not to the phone or the laptop, that's to the whole house, to the router that connects to the internet. For that, they have come up with some solutions like carrier-grade NAT and things like that, that what they do is they share one IP addresses among multiple customers of that operator. This is something similar to what happens with your router connection. Your router at home has a public IPv4 address, most probably, and that IPv4 address is shared for all of the devices that are inside your local network. Then the router assigns internal IPv4 addresses to the devices connected to it and knows how to route the traffic. So for example, if there's a device here that wants to connect to some website, this device will initiate the connection with that website, and the router will say, okay, we'll see that that device has sent a package going to that website, and then when the website answers, it's going to know who to forward it to. What the website sees is just the IP of the router, but the router is intelligent enough to forward it to whoever started the connection. What solutions can we have to this problem? We have more and more devices, more and more servers, more and more demand for IP addresses at the end, and there is already a solution. In fact, the solution was implemented in the Linux kernel in 1996. The solution is called IPv6. IPv6 stands for Internet Protocol version 6 and solves this problem of the reduced number of IP addresses. How many IP addresses are there in IPv6? It's a crazy amount. There are 2 to the power of 128. That is a crazy number. Let's think about it. You could assign to each atom on the surface of Earth one IPv6 address and still have IPv6 addresses left to do the same thing with 300 other planets of a similar size. Crazy. So IPv6 is not only a solution to IP addresses on Earth, it's a solution for interplanetary networks. It looks like IPv6 would solve the problem, right? We would have a huge amount of IP addresses and never run out of IP addresses again, at least not in the next centuries. Why aren't we using IPv6? Only 40% of the internet connections currently use IPv6. This is very sad, since it has been implemented already from 1996, and the problem of the scarcity of IPv4 addresses has only grew since then. The problem is that telecom operators are reluctant to implement the change because they have a lot of routers, they have a lot of equipment and infrastructure that is designed for IPv4. So the change to IPv6 is a huge cost, and that cost for a lot of them is higher than the cost of buying more IPv4 addresses. Anyway, it's interesting to see how some number that looked huge when the internet started, and it wasn't even famous, or they didn't even have in mind the repercussions that it would have, 4 billion addresses seemed like a crazy amount of number. Now I'm wondering if 2 to the power of 128, that is the number of IPv6 addresses, will also be a number that we find insufficient in a few years. What do you think? Will we ever run out of IPv6 addresses? And why aren't we using it already?